Okay, we're going to take a look at 4 examples of exponential equations. In the first one, you've got 2 to the x, and you have to look, I need to make this a power of 2 somehow. Well, your first thing is looking at 16, and you should know the powers of 2. They go 2, 4, 8, 16 is 2 to the 4th power. But then you have to be able to recognize what a negative exponent is all about. 1 over 2 to the positive 4 is really 2 to the negative 4. And now you're looking at your answer. You see how we made the base the same? That's the principle of the whole trip here, is to get the base the same. Now I can see x is minus 4. Let's look at the next example. Well, this looks kind of scary, but let's just try it. So what you do, this 0.6, I think it's a little easier to think of it as 6/10. And then if we just do this thing of 6/10 is really 3 over 5. Well, that's kind of smart. Now, if we divide both sides by 3, 3 divided by 3 is 1. 3 divided by 3 here, if we divide by 3 or multiply by 1 over 3, the 3's will cancel. You'll get 1 over 5. And what's 1 over 5? It's really 5 to the minus 1. And now we're looking at the answer. See how we got the bases the same? So x is equal to minus 1. Let's look at this next question. Now it looks a little scarier, but let's try and get the base the same. Well, 9 is 3 squared. 27 is 3 cubed. And you have to know, when you take a power and you raise it to the power of x plus 1, you multiply it. So that's why there's 2x plus 2 and 3x here. Now that the bases are the same, we can just the only way they could be equal is if 2x plus 2 was equal to 3x. Then all we do is subtract 3x, subtract 2, we get minus x equals minus 2, so x must equal 2. Let's try the last one. Ooh, that looks scary. Well, you have to know that a 5th root is really a power of 1 over 5. That's your whole idea of being able to look at roots here and change them into rational exponents, into a fraction. So if it was third, it would be a cubed root. 1 over 4 would be a 4th root. 1 over 5 means it's the same, just a different way of expressing the 5th root of 4. Now 16 is 2 to the 4th power. This is 2 to the x plus 2. That makes it 2 to the 4x. Now 4x, if we multiply two things with the same base, we add this stuff. So there's 5x plus 1. This 4 is 2 squared. As Mr. Autry and all the teachers say, it's really a good idea to put it as powers of primes, because now that's 2 to the 2 over 5. Hey, we've got the bottoms exactly the same. The only way they could be equal is if the tops are equal. So you go 5x plus 1 equals 2 over 5. I would multiply everything by 5. They subtracted 1. If you multiply everything by 5, you'd get 25x. And then you'd have a 5 here. You'd subtract it from 2. You get minus 3 over equals 25x. And then you divide and you get 25. They did it differently here in this textbook. They took away 1. 2 over 5 minus 5 over 5 is minus 3 over 5. And then they divided by 5 again, or multiplied by 1 over 5, and they got x. 5 times 5 in the bottom. Imagine you're multiplying by 1 over 5. You'd have minus 3 over 25. Well, there's 4 questions. We'll do one more, a little bit trickier question in the next slide.